Okay, so let us go ahead and continue. And okay, let's think about our solar system, right? What we used to think, and you'll still see this out there, the phraseology habitable zone, right? Meaning habitable by life forms that are similar to us. It's not a good term, and I'm going to motivate you to use a different term. Okay. This is also referred to as the Goldilocks zone. Not too hot, not too cold. But a better term is the surface water zone, because that's really what you're talking about. The place where water can exist on the surface in liquid form, right? Earth, Venus, and Mars probably all had surface water in the beginning, before Venus became a hellish environment. Okay. And what the heck, let's talk about Venus right now. The best scholarship is that Venus had two problems. Plate tectonics never, for various reasons, never got going, and the surface remained one solid mass. So the only, instead of being able to have like volcanoes and rift valleys and, subduction zones and volcanoes and stuff, the only way for lava to get out to the surface would be for a fissure to open up on the surface, at which point, millions, billions of tons of lava just spewed out. And the best computer models are saying that there was this runaway volcanism, and a planet can absorb a lot of carbon dioxide and sequester it in the oceans and trees and whatever. But if it gets to be too much, there is a tipping point beyond which there's no more resiliency in the system. And what happened then is that we got a runaway greenhouse effect, and the temperature just skyrocketed. So that's how Venus died. And it would be interesting to with the right technology, which we currently don't have or anything even close, to do some archaeology on the surface of Venus and see if there's any traces of that earlier environment, or whether it's been completely, every inch of the surface of the planet has been covered over with lava. Anyway. Okay. Also, physics says past Mars, no surface water, either now or ever. Because when you're dealing with a surface, you're talking about solar radiation. You can't get appreciable amounts of heat from other places. And that there just isn't enough. Okay. Now, the surface water zone in our solar system shifted. It used to be Venus and the Earth, and Mars was too cold. It was out there. Most of the water would have been ice. So as the sun heated up, because it started, and a little bit of thermonuclear reaction started, and then got more and more and more, and it sputtered to life, as it were, and then it heated up, right? And as it heats up, more and more ice turns into water, and during that first billion years that the sun was was a sun, our sun was a sun, the surface water zones started shifting because the sun was getting hotter. And so the surface water zone, Venus is now on the inner side of that. It's out of the surface water zone, even if it weren't a hellhole. And Mars has shifted in. But you know what happened with Mars? So here's where we get into a little bit more physics. And this is stuff you know, so don't panic. All right. How do you turn ice into water? Well, you apply heat. Okay. You can have heat from deep inside the planet. You've got Iceland runs on thermal energy. Quite a few European nations are using thermal. New Zealand is a leader in thermal energy, using a geological heat, volcanoes and so forth. I mean, hot springs and all that, volcanic stuff, to take the super hot water and have it run turbines and generate electricity. And okay, not so much in the US, even though we've got plenty of geological energy available, especially in Wyoming. Wyoming could become a real energy powerhouse. Note to the governors of Wyoming and Montana, a joint effort here could enrich your states immeasurably. All right, so the point I'm getting here is when you're talking about ice, when a scientist is talking about ice, it's not necessarily water ice. It just means something that's frozen. Okay, so in my most recent science fiction novel, I have people going to a resort on Pluto where they're playing in the nitrogen snow, and so okay, snow and ice just are talking about the physical properties of the thing. So when you see somebody saying Mars has water ice as well as carbon dioxide ice at its North Pole, that's what they're talking about. Okay. The other thing to keep in mind is that there's another way to get heat other than lighting a fire, a geological fire, right? Volcanism. And this is the one that you know all about. Your hands are cold. It's 17 degrees Fahrenheit outside my window right now. So three guesses what season we're in. I live in the mountains of Southern Oregon in a wonderful rural area surrounded by forest and bears and deer and puma and bobcats and raccoons. And it gets very cold in the winter. So if I forget and don't have the gloves, I've got gloves in my pockets all the time, but if I'm wearing a coat that for some reason I didn't put gloves in, and my hands are cold, what am I going to do? I'm going to create friction, right? Now, there's a lot of ways in nature to create friction. Things can rub against each other. They can also flex, right? The expansion and contraction, right, creates frictional forces. And the Jupiter in our solar system is so huge that the moons that are closest to it, as they move in their orbit, they get slightly closer, slightly farther away. The pull, the contracting will create a lot of internal heat, right? So the first moon in is just, it's so volcanic, it's too close to Jupiter. But the other three are having, they have internal warm, salty oceans, because the ice a kilometer or 5 below the surface is warmed by this friction, right? And right. And so the moons, as they get, past each other, are generating frictional forces. And as they interact with Jupiter, there's more frictional forces. And that heat is keeping those oceans warm. And because there's some rock at the bottom of the ocean, or dissolved in the ice, that's where you get the quote unquote salt. Okay. So that's another source of heat, right? Is these frictional forces. So when you're looking at a potential life source, it's not just how close are they to their sun, but how close are they to each other? Because two planets, if we don't have planets that are like passing really close, astronomically speaking, close. But there are other solar systems where the planets are stacked a little closer together. And as they pass each other, they're going to be creating these frictional forces, and you'll find things happening under the surface that you might not expect. So just something to think about. Okay, why are we now so excited about life in the snow zone? 2018, so not very long ago, 600 kilometers from the South Pole, 1 kilometer deep of ice, complex life forms. Now, obviously, they didn't evolve from bacteria. Actually, maybe that isn't obvious, because how long does it take for snow to completely fill up a lake bed, right? And to turn into nothing but ice, and then put a kilometer of additional snow getting compacted into ice above it. We're talking millions of years. All right, and that's as long as Antarctica has been in near the South Pole. It migrated plate tectonics from a tropical location. All right, so obviously there was something there that managed to survive. Right now, we don't know. We need to look at, okay, they're tardigrades, they're spiders, but are these brand new species? They probably are. There's been enough time for evolution to have happened. So, but these are water lakes, right? That they have no contact with the surface. It's a completely self-contained system. And another lake in 2013, which is why they went looking in Mercer. And of course, there's bacteria all over the Antarctic continent. Right now, warm, salty, underwater oceans that we know of, 100% got the data. All right. These probes, right? Ganymede, Enceladus, Triton, Europa, Titan, and two of the dwarf planets, two of those KBOs, Eris and Pluto. So there are warm, salty oceans out there, and please note, look at that list of moons. Triton is a moon of Neptune. That's way the heck and gone out there. All right. So all four of the big planets have interesting moons in terms of life as we know it. All right. So NASA's research priorities. Number one, okay, the first thing that we're focusing on is life in our solar system, right? And that's why there was an intense interest in Mars and Venus. Okay, once we realized that Venus was a hellish scape, all the attention was on Mars. Okay. Now there's more and more interest in the snow zone. Now it takes 10 years for a probe to get there. The outer planets are immensely far away. When I look up at the sky and I see Jupiter shining bright, Saturn shining bright, and through binoculars I see Uranus and even Neptune. No, Neptune is the telescope anyway, but even in my tiny telescope, Neptune, right? It's immensely far away. Okay. And NASA is continuing to study extremophiles on Earth. And then last priority is exoplanets. Okay, so NASA is also looking at the really fun stuff. Let's go back. Can I go back? I don't know how to go back. Anyway, there we go. NASA is looking at exoplanets and in terms of the most likely surface water candidates, right? So, and also looking at what's visible, right? What's possible, right? 4 light years away to Alpha Centauri. So we know that Proxima Centauri, which is Alpha Centauri C, it's a triple star system, two relatively sun-like stars. There you go. 2 of them in a wide orbits. Each one of them has planetary systems, and the 2 Oort clouds don't interact with each other. It's wow. That is a very wide, band for it to be the gravity to be holding these 2 stars together. And there's a 3rd star that is revolving around the 2 of them. And Proxima, that 3rd star, has its own complete solar system, and that solar system doesn't seem to be interacting with Alpha Centauri A at all. But that's what I just said is pretty darn close to wild speculation. So forget I said it. Now, if we're going to be looking at things at a distance, and we're talking huge distances here, in our solar system, it's too far for anything else, but in our solar system, you can see variations in time. Now, bear in mind that there are seasonal color changes on Mars. And people said, oh, it's the summer in the northern hemisphere and the northern ice cap is melting, which it was. So those color changes must be life. Oh, no, just chemical changes. Water interacts with rocks. All right, now here's the key: presence of and percentages of specific gases. Okay. The fact that something has gaseous oxygen means pretty darn close to nothing. It's the percentage that you would expect based on physics and chemistry. If the percentage is off from the prediction, then it could be a sign of life. Titan has 3 things that the model does not predict, 3 things that are wrong. So either the model is severely flawed, or there's life on Titan on the surface. It's eating all this stuff. Okay. And methane. Okay. And the reason I bring up oxygen is because we used to, back when we were kids, right, used to say, oh, we're looking for signs of life, therefore we're looking for oxygen. No. Percentages of isotopes, right? For example, life as we know it preferentially wants, I believe it's carbon-12, and not carbon-13. So if you see, long-range chemistry, you see that there's, on the surface of planet or moon X, there's a lot less of the carbon isotope that life likes to absorb. That could be an indication that there's life, even if you're not detecting other signs of life. Okay. Oh, and that first bullet, the null hypothesis bias, means that you approach everything with the assumption that nothing's happening. What I refer to it as the curb your enthusiasm, right? Don't get, because human beings, we get all excited about something, and then and our mental, we get into a mental cognitive tunnel where we want something, so we start seeing it and not seeing everything else that's also there that might be telling you, no, it's not true. Okay. So become a person with a null hypothesis bias, right? Now, yeah, so isotopes. Another thing is the how we discovered that Earth's water came from the Earth, not from comets. Different form of hydrogen. All right, organic molecules. Okay, I need to, please, everybody, write this down with a pen 25 times. The entire universe is full of organic molecules. Organic just means it has carbon and hydrogen, which are 2 of the most common elements in the universe. There are big, complex organic molecules on comets, on asteroids, on the surface of, out floating around in, intrastellar space and interstellar space. Okay. The fact that there's carbon and hydrogen is not exciting. If you didn't have carbon and hydrogen, well, that would be interesting. Okay. All right. And then, of course, one of the best signs of life on another planet is signatures of technology. If people are doing an alien version of I Love Lucy, okay, beaming in from Epsilon Eridani, like, oh, hey, yeah, okay, there's probably life on that planet. Eridani is another one of those yellow dwarf stars. It's just like our sun. And so the aliens are always from Epsilon Eridani. I think the Vulcans from Star Trek are from Epsilon Eridani. I can't remember. I'm so focused on my own my own alien universe. Okay, and then you can also, if you get rocks, which is what we did with the moon rocks, you can look at minerals and microscopic structures, and because life changes the mineral world. Okay, but be careful, right? There was a false report of extinct life on Mars, which is still floating around out there amongst people who don't read the journals every week, like Rick and I. There was a chemical that it looked like a worm, a segmented worm, right? Oh my God, there's life on Mars. No, the people who were making slices contaminated the study materials. So yeah. Now, it's so easy to be fooled if you just look at one thing, right? For example, Mercury has oxygen gas, right? Life generates methane. Those are cows, and they fart methane. One of the arguments against cattle, in addition to environmental degradation and heart disease, human health and humanitarian reasons, is that methane is contributing to global warming. And if we started raising cows as pets and had billions fewer of them, and ate tofu burgers instead, we could slow global warming because of the methane. Okay, volcanoes, right? Tons of carbon dioxide and methane and other bad stuff into the atmosphere. Okay. Organic molecules, right? Lots of organics are everywhere. It's just chemistry. And we're human beings, right? And so why do people rush into print with things that haven't been verified? It's because, for example, the first person to find an exoplanet rushed into press, and it turned out there was a real find, because it was another team 2 days later reported it to the same agency, and he would have been scooped. There goes his tenure, right? There goes his worldwide fame. There goes his footnote in the history books. So as long as that's the case, and the Nobel Committee will only name 3 people for a prize. They won't include 16. So you can't be inclusive. You gotta do this stupid stuff. So when you first hear about something, don't curb your enthusiasm, right? Give it a couple of months so all the other scientists can say, no, no, because, and here's all the evidence against it, right? You got to give the skeptics, the rest of the scientific community, a chance to weigh in. The reporters are always going to go, ooh, right? So life as we don't know it. Could life exist without water? And that is the thrilling subject of our next video.